Okay, yes, to the Professor Dr. Dolphy Gilpin, and we're looking at fermium, fermium, and here we have fermium FM. So we're turning over to channel 100, FM, frequency modulation. Okay, no, this is the element fermium with an atomic number of 100 and an atomic mass of 257. So you could always remember it as channel 100, frequency modulation. FM. And for amplitude modulation, we would have americium, AM. That is just a little correlation there. So FM, fermium, atomic number 100 and atomic mass 257. Let's look at it. It doesn't have much use more than for research. It's also synthetically produced. Fermium. So here we have fermium, atomic number 100, and atomic mass of 257. And one of the positive about this deck of cards is that it's quite portable. I've taken it with me on my travel. I don't have to have anything I fold up. It's very easily put in a package, and I have it with me. I can carry around these 3-portion periodic table here. Just want to make my travel a bit lighter. Fermium here. FM 100, 257 atomic number. Radon 5F12 7S2. That is the electronic configuration. Radon 5F12 7S2. And it's a radioactive and toxic element, as usually, of the actunide series. And the metal is solid at room temperature. Fermium is obtained in micrograms from neutron bombardment of plutonium. So here's plutonium again. By bombarding neutrons with plutonium, you get fermium. And this has to be done in a nuclear reactor. Now, fermium is named after the nuclear physicist Enrico Fermi. So yeah, the nuclear physicist Enrico Fermi, this fermium is named after him, and I believe the same Enrico Fermi was the one that first split the atoms, if I'm not mistaken, and he did that at the Rutherford Laboratory down there at Columbia not Presbyterian, that's where I went for medicine, but Columbia University, which is at 116th Street, the Rutherford Physics Lab there in the Pupin building, which also hosts the Rutherford Observatory, that is the telescope. So that's Enrico Fermi. I think he did this in 1939, but let's see these dates. I will confirm it or change it if it needs to be changed. Yeah, Enrico Fermi. He was the one that split the atom, and he did that at Columbia University in New York, I believe, because there are other Columbias in 1939. Now, this element is also produced from the debris of the hydrogen bomb. are from the hydrogen bomb test. So that's how we get some fermium from the debris of hydrogen bomb test. Let's look at this electronic configuration or shell configuration. We have in the first shell 2 electrons, second shell 8 electrons, third shell 18 electrons, fourth shell 2 electrons, fifth shell 30 electrons, sixth shell 8 electrons, seventh shell 2 electrons. And that's how you get the radon 5F12 7S2. Now, fermium is believed fermium is flammable, or it is believed to be flammable like the rest of actinide series metal. And you know, most of them in the powdered form give spontaneous combustion, especially in the powdered form. You get this spontaneous combustion and the reaction with air. It's only used for research, really, because there's not much of it going around as well. It's in the rear because, as we said, you can derive it from the bombardment of plutonium and also from the debris of the hydrogen bomb. You get some small amount of fermium there. But it is produced from a neutron bombardment of lighter metals. And it is one of the heaviest metals that can be made from neutron bombardment of lighter metals. All right, let's look at some fermium reaction here. Reactions have not been proven, but it is highly suspected or predicted that fermium would react like other actinide series radioactive metals, as it will react with air and steam and acids. Most of the actinide series metal does that. And in the powdered form, it becomes very flammable. And also, it's predicted that fermium will also react with the halogens. Most of them, fluorine and chlorine and iodine and bromine. So those are predictions, as there's not enough fermium going around to actually prove these reactions. So we extrapolatively predict these by looking at other metals that is in the same group and that behaves the same way because of its shell configuration and being assigned to the same group. So that's just a short introduction on fermium. And as you know, if it's going to have a modern name, it would have been nil nilium. It would have been nil nilium. And 101 would have been nil neum. Nil onium. But fermium. And here we have the description of fermium completed here. Not much to say because there's not much use, but it's used in for research.